Did you know you can use polynomials to count? Think of a six-sided die. We can represent this as a sum over its individual faces. In a fair die, there are six sides, each with a different number, which we can write as the following polynomial, where the powers of x tell us how many dots are on each face, and the coefficients tell us how many faces have that number of dots, which in our case will be powers from 1 to 6, with each having a coefficient of 1. You might be questioning the idea that these two objects are equivalent. To clarify that, consider throwing two dice. This will be equivalent to squaring the polynomial. Once again, this is not immediately clear, but look what happens when we expand the polynomial out. Now we have 11 different terms, ranging from x squared to x to the 12th. And more importantly, they don't all have a coefficient of 1 anymore. The coefficients now represent the number of combinations that can give us each number. X squared has a coefficient of 1, because we can only get it by rolling a 1 on each die. X cubed has a coefficient of 2, because we can either get it by rolling a 1 on the first die and a 2 on the second, or vice versa, and the pattern continues. If we place all the terms of the polynomial in a line, then we can represent this using a chart, where we can clearly see that a 7 is the most likely outcome of rolling two dice, with 6 different combinations adding up to 7. And we also see that this is a completely symmetrical system, with a 2 being as likely as a 12, a 3 as likely as an 11, and so on. So there you have it. Now you can answer yes if someone asks you,